I am Kristen Brown. I am a fifth-year chemistry Ph.D. student here with a friend and colleague, Matt Glazer, to talk to you about the work that we're doing on campus to help build a cohesive energy and sustainability community. Christy touched on this when we heard from Dan earlier about breaking down boundaries and building interdisciplinary efforts among students on campus. And with the Northwestern Energy and Sustainability Consortium, or NESC, we're really trying to embody that. So right now, there are 4,200 students connected to Northwestern energy and sustainability efforts. So this is through courses, this is through listservs, this is through the commitments to action. This encompasses a broad scope of activities. That 4,200 number is 26% of Northwestern's total undergraduate and graduate populations. It's more than the largest major on campus, which is economics, by far. It's twice as high as the enrollment in the class of 2018. It's larger than the entire enrollment in the graduate school at Northwestern. It's a huge number. It's on par with the entire school of Weinberg College of Arts and Sciences. This is a huge population that shows passion and enthusiasm about these issues. Their involvement spans 20 different organizations, some of which I've shown here and some of which you've heard people talk about over the course of today. We kind of break this down a little bit. These numbers represent the largest undergraduate, graduate, and MBA student organizations on campus. So Wildroots, ESW&C reach almost 1,900 students, and you can see the numbers for the graduate school, and Kellogg's Energy Club has almost 400 full-time students engaged in energy and sustainability efforts. But while this community is extremely vast, it's also extremely disconnected. So only 7 students are connected to 4 or more of these organizations. Only 23 students are members of the 3 largest undergraduate student groups, and 87% of students are only connected to one organization. As NESC, this is something we really want to change. We want to, as Christy said, break down these boundaries that disconnect students and go from a picture that looks like this to one that looks like this. And we aim to do this through 3 different areas: building awareness of these organizations, providing these organizations with the support they need to reach the entire campus, and really the crux of what we want is to have a platform for collaboration between these organizations who all have different missions but are united under a common goal. NESC, currently, we are comprised of 10 student leaders who represent a variety of the organizations that I showed you earlier. We offer new opportunities, interdisciplinary speakers. We had Justin Gillis from the New York Times out a couple years ago to give a fantastic presentation. Matt will talk about our student-led seminars, which are really kind of the seminal work that we've done. And Christy showed a picture of our career fair. We just hosted the 2nd Energy and Sustainability Career Fair that drew a great number of really passionate students. Every year, we're building new initiatives that really work to build a stronger and more cohesive community. I'm going to turn this over to Matt, and he's going to go into a little bit more detail about some of the work that we've been doing.
All right, thank you, Kristen, for that introduction and overview of NESC as a whole. So I'm going to talk a little bit today about our student-led seminars and also give you a little flavor for what those are like. We have developed 2 student-led seminars, a Business and Technology of Energy seminar series, to give the business case overview and technology overview for a broad swath of different energy systems and groups. And this is something that we noticed a deficiency in what was, or at least a white space in what was available on campus, and we wanted to try and fill that as best we can. So I founded the Technology of Energy seminar series, and now I'll tell you a little bit about that. This is a collaborative project between NESC and the Northwestern Energy Technology Group, a graduate student group designed to promote information and awareness of new energy technologies. I had a lot of help in this, and I have to acknowledge all my seminar leaders here in helping me to put together and run this series. This series essentially is a win-win for us. As graduate students, we sometimes don't get a lot of opportunities to practice our presentation skills, and we have to develop teaching skills. And so in order to boil down all of these energy concepts into something that anyone really can understand, and understand in a differentiating manner, we have to figure out how best to put this together. So that's a professional development for us, in addition to everyone who signs up, other PhD students, master's students, undergraduates, MBAs, really anyone at Northwestern can sign up, can apply and sign up for these programs to learn more about energy technologies. So how does the actual series work? To give you a little flavor of it, we cover the full gambit of commercially available and things that are almost commercially available in energy technology. All the way from oil and gas to energy storage and renewables, the electric grid, etc. We don't talk about energy technology in terms of just what are the inputs, what are the outputs, or what is the scientific governing principle. We talk about energy technologies in the same way that the military talks about their weapon systems, not in terms of the bullets or the amount of men that it needs, but really about the capabilities. What can it bring to the situation? And we want to talk about energy technologies. What can it bring to us as a society? Without getting into the really gory scientific details that are going to go over some people's heads, unfortunately. So, because this is Northwestern and this is an academic institution, I'm going to give you a little quiz. I promise it won't be too difficult. So I'm giving you a little flavor here for the Technology of Energy series with a short vignette of hydroelectric power. So hydroelectric power, we've traditionally thought of it as a steady baseload source, but is it truly a steady baseload energy source or an intermittent source? Hydroelectric power is using water from precipitation to generate electricity. Baseload means that it runs pretty much 24/7, almost 365, and has a pretty steady output, versus intermittent, which occurs really when the sun shines or the wind blows. So, how many people believe that hydro is a baseload energy source? Go ahead and raise your hands, don't be shy. Okay. How many people believe it's an intermittent energy source? Okay, got some nuanced thinkers here. Well, you're both right. And this is not entirely the traditional way of thinking. The traditional way of thinking is that hydroelectric is only a baseload source. And in the scale of seconds, minutes, hours, even a day or two, this is pretty much right. But if we look month to month, or in this case year to year, there can be very stark contrasts in rainfall and snowpack. So if we take a look at California and the Sierra Nevadas, last January 2013, there's not lots of snow on there, looks pretty nice. This means that all this water is going to be flowing down through California, through their hydroelectric dams and generating electricity. Go into this January, there's a drought, pretty severe drought. And not only does that mean that the skiing is not as good and maybe the agriculture is stressed, but also means that we actually get a lot less energy out of the water. You can see here a 10-year average that we get a pretty predictable seasonal variation associated with kind of the melting snowpack, increasing energy generation, and then as we run out of water into the fall, it goes down. We have the range for the last 10 years. And then we have the drought of 2014, where we have a significant decrease in the amount of electricity being generated because there's simply just less water there. So this has important climate implications, because where do we get this difference here? Where do we get all these megawatt hours? Primarily from natural gas. Natural gas is something we can easily dispatch, turn on and off. And we can see here the decreases in hydroelectric power, shown in the dark blue, almost mirror the increases in the use of natural gas over the last 10 years. So this means that as we're getting to a hotter and drier climate, we're having to make even more carbon emissions in order to make up our electricity generation for that. So this is the traditional view of hydro as a baseload source. But hydro also has a number of advantages that other energy sources don't, and that's really a high ramp rate. This is especially important as we increase the penetration of renewables, especially this gigantic wind farm here out in California. So let's say it's a relatively windy day, we get a 7 to 10 knots of wind coming out, and this farm is generating 100 megawatts of power. That's wonderful. We can power our lights and charge our electric cars and all sorts of things with this energy. And let's say we get a huge gust of wind, and now the output of this farm doubles. Normally on the grid, we might have to curtail or reduce the actual amount of power that we're getting from this wind farm and essentially waste this intermittent resource. But if we're properly managing a hydroelectric, we can simply close one or two of these floodgates.